Okay, folks, I've accidentally recorded this upside down. So now I'm having to record from the screen because I managed to flip it. I was trying to use Clipchamp, but it's going to take forever. So I'm going to record off the screen and then upload this to YouTube. So let's, without further avail, let's do a screen recording. Okay, folks, this is a CSSA trial looking for reactions that supports A and B. I'm going to do it two different ways. One's using the true moment arm, which is the way that was explained in the actual marking criteria. And then I will also do a second version of this explanation using a true moment arm as well. So we're going to do a couple of different methods. Okay, so these problems nearly always begin with this idea of finding reactions at A and B. That's the first thing you need to know. It's also telling you in this question, it's always a good idea to underline keyword too. It's asymmetric truss. So once you know one of these measurements should all be the same. Now, from our experience with this question, we know that if you were to build a triangle with dimensions like this, 140 making 180 degrees, so that would be 140 degrees. If we made this triangle, it would not be with these dimensions. So these dimensions were actually a little bit out, which is a little bit annoying, but we'll just use the dimensions that are giving it to us. For instance, that height would be slightly more than 1,000. So the question was not designed very well. So that's the first thing I want to say. In case you start getting slightly different results, I'm going to use the dimensions that are given on the diagram for the sake of making the question answer a little bit more clear. And if they ever give you measurements on a diagram, it's probably best to use the measurements on the diagram rather than calculating to see if they're correct or not. It'll save you a whole lot of pain. Okay, so we need to take moments about our point A. And so we know that if the structure is in equilibrium, sum of forces vertical and sum of forces horizontal is going to be equal to 0. Let's just do this. Forces vertical equals 0. Forces horizontal is equal to 0. And the sum of moments, let's just go this way. I'm saying clockwise is positive for a moment. Sigma moments about the point A is equal to 0. In fact, sum of moments in general is going to be 0. So that's for an equilibrium situation. A lot of you missed this force here in your calculations. We know that we've got a force going across, we've got a force going down, and because we're taking our moments around here, our reaction at A, which is what we're trying to find, will not come into the equation because it doesn't create a moment. Any force that's acting through the pivot point does not create a moment because it's not at a distance from the pivot point. So here we know reaction B is going to be only vertical, even though we've got a horizontal force acting here, because this is a roller support. And because the roller support moves, it doesn't react in the horizontal sense. It only reacts in the vertical sense. That's something you need to also keep in mind whenever you're doing this type of problem. Normally a truss bridge like this will have a roller at one end. So if you see a roller, think vertical only. Okay, sorry I'm babbling on, but I'm trying to give myself time to think because it's 3:30 and I'm really tired and my brain is not working. Okay, so we're going to take moments. Sum of moments. About point A, we're going to say clockwise is positive, is equal to 0. Therefore, we can say 7, which is 7 kilonewtons, times the distance. Now, the distance is the perpendicular distance from the pivot point. So if we transmit this force this way, what we're really looking for is this distance here, because that's the perpendicular distance, okay? So we know that perpendicular distance because it's written on the diagram. It's 1,000. So we're going to say 7 times 1,000, and that's going to be positive, plus, this is 15 newtons acting straight down, kilonewtons acting straight down, distance 6250 times 6. Times 6250 clockwise. Now, we know our reaction at B is going to be vertical and it's going to be anti-clockwise. So this is where we're going to say subtracting RB times 2 times, because this is symmetrical truss, so we know this is also going to be 6250. So because Mr. Komonos' brain doesn't work, 6250 times 2 equals 12,500. Of course it does. So now we can say 12,500 RB is going to be equal to, I've taken it over the other side of the equal sign, because this is 0 equals this, because we know that the whole thing is going to be 0. So 12,050, 12,500 RB is going to be equal to 7 times 1,000 plus 15 times 6250, which is equal to 100,750. We're going to divide by 12,500 to get rid of the 12,500. So we're going to get RB is equal to 8.06 kilonewtons, and we know it's going up. And that agrees with our answer here, 8.06 kilonewtons. Yay, we got that one right. Okay, so now we need to calculate our reaction at A. Now, this is where normally if you take moments, the next thing you're going to use is this idea of sum of forces, okay, vertical and horizontal, to calculate what is going on. So, what we're going to do is we know that the only force that's acting horizontal is this 7 kilonewtons that's going this way. So if the 7 kilonewtons is going that way, then we know that our reaction at A is going to be, the reaction A horizontal is going to be in that direction. And this is reaction A vertical. And that's what we're going to try and find out now. So let's say, let's get our, let's go sum of forces horizontal is equal to 0. And we know that to the right is positive. Therefore, we say 0 is equal to 7 kilonewtons plus RA horizontal. So RA horizontal, making it the subject of the equation, is minus 7 kilonewtons. So now we've got one of the figures we need. Now we need to work out our other vertical force here. So we're going to say sum of forces vertical is equal to 0. And we know that we've got acting up. We already worked out 8.06. So we're going to say 0 is equal to 8.06 because it's acting up, positive direction, minus 15 kilonewtons because that's acting down, plus RA vertical. So we can say 8.06 minus 15 equals minus 6.94. So 0 equals minus 6.94 kilonewtons plus RAV. Therefore, RA vertical, making it the subject of the equation, we take this negative over the other side of the equal sign, we get 6.94 kilonewtons. Okay, so we're very close to getting our reaction at A now. I'm going to just go to the top of the page here. We know that we've got minus 7 kilonewtons, because we worked out that just a second ago. We also know we've got 6.94 going up. So we have a triangle. You can use Pythagoras' theorem to solve this. We can say that the resultant at A is equal to the square root of 6.94 squared plus 7 squared equals 9.85. And I wrote down this answer here wrong. It's 9.86 in the answers, and I was worried that I'd got it wrong then. It is 9.86. So that is the correct answer. Sorry for any confusion. So yep, 9.86 when you round the answer. And if you really wanted to be pedantic about it, for these questions here, when you said reaction at B, you should do an arrow, because it is a vector, and they should actually be asking you for direction here. And obviously, you can do tan minus 1 opposite on adjacent is equal to 6.94 over 7. So shift, and then we go inverse tan 6.94 divided by 7, close bracket. That'll give us our angle 44.8 degrees. So you could go over here. We know that our direction is that way. You go 44.8 degrees. Sorry. Yep. So that is the answer, 9.86 and 8.06 degrees. And I know I was saying two methods. There's two methods for calculating the